Mega cranes in action. 3 monster machines, 1 mission, installing railroad bridges. A tandem lift involving 2 mobile cranes and complications.
If the weight distribution isn't even, the load can end up swinging.
They communicate via radio.
I'm lifting my side again. Watch your fingers.
Don't yell, I can't understand.
A gigantic lattice boom crawler crane. Alarm while lifting out a bridge.
From up here, I didn't notice that something shook.
Erratic weather while lifting in the new bridge.
A gust of wind has caused the bridge to twist unexpectedly.
And making adjustments with muscle power. A crane is deployed to a wind farm by Jever, near the North Sea coast. It was erected in 2002, and it's now showing signs of age. The rotor hub of this wind turbine has to be replaced at a height of 97 meters. 2 cranes were used on the job. One of them, this monster, a Liebherr LTM 1750, the largest mobile crane permitted to drive on German roads with mounted telescopic boom. It can lift up to 750 tons. And with an additional lattice luffing jib fitted, has an impressive maximum working height of 152 meters. The gross weight of the 9-axle giant, 108 tons, 12 per axle. Now it's needed on another job site. But because of its size, 22 meters long, 3 meters wide, and 4 meters high, it's only allowed to drive on the road between 10 p.m. and 6 a.m. It's just before 10 o'clock at night. The driver arrives. Qualified welder Bernd Eichwurzel has been a crane operator since 1995 and has been operating the 750-ton crane since 2014.
I'm now driving from Jever toward Flensburg, where a railroad bridge is to be installed with a second large crane.
The 8-cylinder diesel engine of the monster crane produces 680 horsepower. 4 axles are driven, and all 9 are steerable. It's just under 370 kilometers to Flensburg, but the telescopic crane has to make 30 kilometers of detours because some of the roads are off limits for it.
Because the road surface would subside, or the curbs break away. Plus, there are many bridges en route that can't take the weight of 108 tons.
Bernd Eichwurzel has 8 hours to cover the 400 kilometers. It sounds like plenty of time, but it could get tight.
There could be an accident, and we could get stuck in a traffic jam. The crane could break down, a tire blow out or something. We could get stopped by the police.
To make matters worse, the mobile crane can't drive around Hamburg, but has to go right through downtown. So Bernd Eichwurzel still has a long night ahead of him. His destination? A building site on the B200, the West Flensburg bypass. 2 weeks ago, there was a railroad bridge here. It had to be demolished because it was no longer reparable. The new bridge is to be erected by several companies, working in close cooperation and under enormous time pressure.
We'll start at the crack of dawn tomorrow with the foundations, then continue with the abutment elements and finally lift the bridge into place on Monday, so that normal rail service can resume here by the end of the month.
Because it's rush hour on the multi-lane highway, the cranes cannot take up position yet. – 6 p.m. The B200 is now closed in both directions. The crew of the crane company moves the barriers out of the way so that the convoy of heavy trucks and cranes can access the building site. Leading the way, another giant crane, the Liebherr LG 1550, a mobile lattice crane whose booms can only be assembled once on site. Built in 1992, it's the last of its kind, still in service in Germany. The LTM 1750 telescopic crane now also takes up its position on the building site. Both cranes need to be fully operational by daybreak. Bernd Eichwurzel first extends the front outriggers. They're not yet in the correct position. The crane operator now swings out the cab, from where he will control the hoisting work toward the adjacent footbridge. The first task? To raise the gigantic telescopic boom.
If he drove into position before raising the boom, it would be under the footbridge, and he wouldn't be able to raise it anymore. So we're raising it now before continuing to the designated point.
Bernd just has another meter to go. Right on the mark. Next, the crane has to be leveled. Bernd extends each of the 4 hydraulic jacks until the crane is horizontal in all directions. The whole procedure is remote controlled.
This here is the bubble level, and the dot is right in the center, so now it's level. These numbers here serve as a guide.
In the meantime, Bernd's colleagues have fitted the hook block assembly. Now, the LTM 1750 can rig itself. The first add-ons are the rear outriggers. Weighing 4.5 tons apiece, they couldn't remain attached to the crane during transit, or they would have made the vehicle too heavy for the road. Once the workers have securely attached the outriggers to the crane with a bolt, they connect the hydraulic and electrical systems. To make sure the crane remains stable when lifting the heavy loads, pads are placed under the outriggers. To save on transport weight, they aren't made from solid steel, but hollow inside with reinforcing partition walls. As such, they each weigh just 2 tons. Bernd Eichwurzel extends the hydraulic jacks of the outriggers. The crane's wheels are lifted off the ground. It's now supported solely by the 4 outriggers that form a square 12 meters by 12 meters in size. The telescopic crane still needs counterweights for the hoisting work. Just the base plate for the ballast, which the crane operator now lowers in place, weighs 11 tons. Then the ballast plates are installed. The smaller ones weigh 5 tons, the larger ones 10 tons. To attach the blocks to the hook, the crew use a ballasting spike.
That's the spike that supports the ballast. It's inserted into the triangular hole and locked in place. My colleague inserts the spike and it goes all the way until it can't go any further. And now it's locked. It latches in place and then the ballast is ready to be lifted.
It takes 5 heavy haul transports just to bring the ballast for the telescopic mobile crane. The second mega crane on the building site, the LG 1550, needs an auxiliary crane in order to load the ballast and rig the lattice boom. The LG 1550 can lift a maximum of 550 tons, 200 less than the telescopic crane. This only applies if the load is right in front of the crane, though, at minimum reach. But the lattice boom crane has an advantage when it comes to larger reaches. This is because the lattice design of the LG 1550's boom makes it much stiffer. The ballast is loaded. Now the lattice boom is rigged. The section being lifted by the auxiliary crane is 14 meters long. To attach the section requires the help of a hydraulic power pack. The eyes of the lattice boom element must line up exactly with those of the heel section. Then the hydraulics come into play. The ram is positioned against the pins and drives them through the eyes. A retaining clip secures the pin in place. Suddenly, there's an interruption. Private vehicles have ignored the roadblock and driven right into the construction site. Mavericks like these are nothing new for Mark Bernschneider. He sounds the alarm.
Yeah, okay, thanks, yeah. Okay, bye. 2 cars were just here saying that the roadblock was open. The site supervisor is going to take a look. I can't believe it, because the highway department closed the road at 6 p.m. It's likely they drove around the barrier. Then they get here claiming there weren't any signs, or they were pushed aside. It's nothing new.
Another heavy hauler arrives at the building site. It's carrying a component for the telescopic crane, the power pack, the 300 horsepower motor for the so-called revolving superstructure. Bernd Eichwurzel sets the 23-ton unit down between the ballast plates. It will later drive the cable winches when lifting the heavy loads and provide hydraulic pressure for the telescopic boom. The weight of the power pack, base plate and ballast plates now totals 204 tons. But the package is still sitting on the carrier. Bernd must now pick it up with the superstructure.
We've just raised the power pack so we can turn the superstructure under it. Then we lower the power pack again. It then hangs off the back of the superstructure. It's then used to raise the ballast again.
The telescopic crane would normally be fully rigged now. But because the bridge to be lifted weighs an enormous 260 tons, it needs an additional add-on, the so-called Y-guying system. It's the only thing that the telescopic crane cannot fit itself. It requires the help of the auxiliary crane. The 20-ton Y-guying system attaches to the boom of the crane and increases its lifting capacity. The final rigging job, reeving the 4.5-ton load block for the lift. Thanks to the pulley principle, the crane only needs to generate 1/10 of the force as a result. The crane operator now raises the telescopic boom. The Y-arm pretensions, bracing it towards the ballast, and doesn't deflect as much when lifting heavy loads. The rigging of the crane is now complete. Seven kilometers to the north of the job site, the bridge that the cranes will be installing is standing by at a rest stop. The so-called trough bridge is 46 meters long, 8 meters wide, 3¼ meters high, and weighs 267 tons. A structural steelworks engineering company built the bridge in sections and then welded them together here.
This bridge was delivered in 4 sections, 2 left and 2 right. This here is the transverse weld, and there's a longitudinal weld running along the center. It's taken around 4 weeks to weld, and we're now at the final stages.
At the moment, the bridge is still resting on so-called elephant feet. The crew of a heavy haul company will now load it onto a modular transport trailer with 32 axles. The men don't need a crane for this, as the platform can be raised hydraulically. There's one snag, though.
The problem is that the parking lot slopes down in one direction. So to make the bridge level, we made the foundations thicker on one side. But now the trailer is standing on an inclined parking lot, which means the distance to the bridge is greater on one side than the other. So we need to raise the left-hand side and add an extra wooden block so that we can then set the bridge down at an angle to the road level. Then we pick up the entire bridge with the trailer at this angle.
First, the transport trailer is raised up hydraulically. Then, a layer of supports is removed from the left elephant foot. The trailer is lowered again. A timber is removed from the left side and the chassis raised again with one layer of timbers on the left and right. The bridge is clear. All that remains is to secure the load in place with the tensioning chains.
Okay.
The bridge is ready for transport. The next morning, construction of the bridge's foundations begins. The foundation plates have already been lifted into place along with the first section of the abutment. The construction workers now have to fill the 3-centimeter gap between the concrete elements. They use an expanding cement for this. It spreads out beneath the precast element. To prevent the mortar from flowing out the sides, a rigid foam seal is fitted to each section of the foundation. The intermediate spaces are filled once the cement oozes out of the vents. Before the next element is lowered into place, the workers first have to grind off the filler tubes. The next one of 50 prefabricated elements weighing a hefty 70 tons is waiting. The workers attach it with lifting eyes. These capture the dog bone anchors that are cast into the concrete. The lifting can begin. Slowly but surely is Bernd Eichwurzel's motto. He now controls his crane based solely on the instructions he receives via radio from the signalman.
Bernd, stop.
Bernd, stop. A bit further forward. Stop. Neck up, Bernd.
Neck up means raise the boom. This causes the load to move slightly upward and toward the crane.
Bernd, stop. Bernd, lead it.
Which means lower the load.
Bernd, down slowly.
Which means down with the load. The precast concrete section is now suspended almost exactly above the one beneath it. The signalman wants to know if it's resting on anything.
How much weight do you still have, Bernd?
70 tons minus 5, so 65.
Something's stopping it. It's not happening.
It's caught somewhere. The concrete section has gotten tilted.
Bernd, neck up, please.
A new attempt.
Bernd, down all the way.
That is, lower the load completely. The bubble levels say everything fits correctly now.
Perfect.
The next heavy hauler is already waiting. One of 42, bringing the precast concrete sections to the job site at half-hourly intervals. But before the next lift, the workers first have to cement the newly placed element with the one below it using expanding concrete. Another incident at the building site. Several private vehicles have sneaked in despite the highway being closed.
It's amazing, isn't it? Amazing. The road is closed, but someone drives in, followed by 3 others that have no business being here. Like on Friday, when 2 cars suddenly appeared here. Like there's a herd mentality or something.
7 kilometers to the north, the gigantic railroad bridge that is to be lifted into place by the cranes begins its journey to the building site. It's 46 meters long, 3 meters 25 high, 8 meters wide, and weighs a colossal 267 tons. Together with the push and pull tractor units, the complete rig is 72 meters long.
Because there are a total of 7 bridge structures en route, and to minimize the risk of tipping over, we're allowing roughly 1.5 to 2 hours for the transit. One of the structures on the way has been strengthened to prevent damage, as it's not strong enough to support a weight of 454 tons.
Because of its width, the transport needs to use both lanes of the highway. Strict conditions apply. It only travels forward at walking pace. The escort crew must constantly check that the sides of the bridge don't hit anything. The men have a long walk ahead of them. Back at the construction site, everything is prepared for lifting the railroad bridge into place. In order for it to be adjusted to the correct height, it has to rest on these adjustable jack posts.
This is where the superstructure will be placed. The bearings will go in here later. There are extra bolts down below. Here you can see the formwork and rebar, and that will be filled with concrete when everything's okay. And once the concrete has set, the bridge will be fixed in position.
Meanwhile, the heavy haul rig with the bridge has arrived. Before the lifting begins, there's a briefing between the signalman and the crane operators.
Okay, a couple of things. We won't communicate using names, but axes.
Oh, that'll be tricky.
Bant is axis 20, and that's axis 10. So how do we want to do it? 10, you slew in there, and he slews out. You can work it out between yourselves.
Okay, we'll work it out.
The crew of the Steelworks Engineering Company now attach the steel ropes to the hoisting eyes of the bridge using massive shackles and secures them with bolts and retaining clips. The operators of the telescopic and lattice boom cranes now take up the strain as uniformly as possible.
Precise coordination between the crane operators is now crucial so that both lift in concert. If the weight isn't distributed evenly, the load may end up swinging.
And the transport modules could also get damaged if too much weight is focused in one place.
Ivo?
Yeah.
Can you take a look? Am I centered?
Looks pretty good from here.
Let's go up to 50.
That is, take up the strain until each crane has 50 tons on the hook.
$130.
Me too.
130 tons each, the ideal weight distribution for a tandem lift. Just a tiny bit of the bridge's 267 tons of weight is left. The crew of the transport company now lowers the platform. Done. The bridge is now suspended freely, and the tractor can pull the transport platform out from underneath it. The Y-arms attached to the telescopic crane ensure that the boom only deflects slightly. The mobile lattice crane doesn't need additional guying for a load this size because the lattice boom is intrinsically stiffer. The two cranes now turn the bridge so the ends face the foundations.
Can I make it over the railing there?
Yeah, you've got to meet a clearance. No, you need to go higher.
The cranes have to maneuver slowly to prevent the bridge from swinging.
Neck down.
The telescopic crane lowers its boom. The ends of the bridge are now suspended directly above the two abutments.
Stop. Lower slowly. Stop.
The two massive cranes aren't able to perform the fine adjustment down to the millimeter. So, the crew of the Steelworks Engineering Company have attached chain blocks to the bridge that they now use to align everything exactly.
Need to lower the boom more here by 20.
The steel bolts on the bridge bearings have to go into the bearing cases, but this doesn't succeed on the first go. The reason is quickly discovered. The rebar inside the formwork is in the way of the pins. They're resting on them. The next attempt.
Question, I'm lifting my side again, right? Don't yell, I can't understand. I'm lifting my side again, watch your fingers. Okay. Axis 20, up please. Stop.
The workers use a crowbar to bend the rebar a little to the side so that the steel pins in the bridge bearing can pass by them.
Both hooks down.
Now, the crane operators can lower the load again. Done. The railroad bridge is now sitting in exactly the right position on the adjustable jack posts of the foundations. After a nearly 2-hour tandem lift, the two cranes have successfully completed their mission.
Everyone worked really well together. We managed to get the bearings into the rebar, and the bridge is resting on the post points. We just need to do some more fine adjustments and secure the bearing.
Secure means cast the bearing in concrete. For the crane operators and their crews, this means de-rig and pack everything back up. They have to be at their next job site in 3 days' time. The Buchenbach Creek, a tributary of the Mur River by Affalterbach, northeast of Stuttgart. The valley has been designated a nature reserve, and this bridge is the only way to cross it. It's used by the suburban trains, for now. The fact is, the 26-meter, 100-year-old steel structure is showing signs of fatigue, and the bridge has had to be strengthened with additional metal struts several times already. DB Netz, a subsidiary of German Railways, is responsible for the upkeep of railroad bridges like this. Project manager Marco Henrichs summarizes the situation.
The authority responsible for bridges won't allow any further retrofitting, which means the bridge has to be demolished. And if the bridge isn't removed, the line could be closed.
Swapping the bridge out is a complex task. Heavy machinery or cranes are not permitted into the conservation area. As a result, the engineers intend to operate from a staging area located 60 meters from the creek. A specially constructed plateau serves as the foundation for one of the most powerful cranes in Germany, the Liebherr LR 11000. The lattice boom crawler crane with a maximum lifting capacity of 1,000 tons is to lift the old bridge out and set it down here on the asphalt. But the crane is still missing its gigantic boom. It has to be 96 meters long for this project. The bridge lift is due to start in a few days' time. The project manager of the crane company is Marco Wilhelm.
This is our biggest crawler crane. It was configured specifically for this deployment and satisfies all the safety criteria demanded for the job. It's a special job for us too, not the typical work we do.
And this man will operate the behemoth. Thomas Klei has previously used the crane to erect wind turbines, but a bridge lift is something special for him too.
Everything is bigger and everything you lift is heavier. You have to rely on the crew, the radio signaller. You need to work as a team for everything to go right. There isn't much you can do with the big crane by yourself.
At the moment, the crane is only fitted with the 42-meter-long so-called gantry. Its job is to brace the main boom using cables. It will later be attached here, and the entire bridge will be suspended from it. The 170-ton superstructure ballast prevents the crane from tipping over with the gantry mounted. The counterweight for both booms is the derrick ballast.
This is the so-called ballast tray. It's a steel tray on which the individual ballast plates are stacked. Because the boom itself is so heavy, we need 165 tons of counterweight just to raise it. And we'll stack it with 225 tons during the actual lift. With this crane, we can load up to 450 tons of ballast.
The main boom consists of several 18-meter-long sections that the riggers have to assemble today to create the 96-meter-long lattice boom. It takes 40 truckloads to get all the parts for the crawler crane to the job site, many of which are oversized heavy haulers that are rolling traffic obstructions.
The problem is trying not to hit anyone else. Most car drivers get pretty mad when my escort vehicle blocks a lane behind me at the job site, but I need a bit more than just one lane.
A single boom section weighs as much as 10 compact cars. For this reason, a 250-ton auxiliary crane is used to help with unloading and assembly. The crawler crane moves forward to be assembled. Its crawlers are 12.5 meters long, 2 meters 40 wide, and weigh 67 tons each. The crane travels on a bed of hardwood boards. This helps to distribute its weight of several hundred tons over a greater area. Crane operator Thomas Klei maneuvers his crane based on instructions given by radio from outside. The crawler crane doesn't have a steering wheel like a car.
Travel forwards and backwards is controlled by foot pedals, either both crawlers together or individually to steer.
Besides instructions over the radio, there are also several cameras to help with orientation. High-tech hardware and software make it possible to perform delicate tasks with such massive equipment.
You can control a crane more easily or more precisely than a PlayStation.
Fitting the enormous section is precision work for the crane operator and crew. Eyes must be exactly aligned in order to join them together. It would be impossible to drive the pins in by hand. A hydraulic ram is used for this. It takes a whole day to assemble the 96-meter main boom of the LR 11000, one of the largest lattice boom crawler cranes in the world. The stretch of track where the bridge is to be replaced has now been closed and the power turned off. Railroad workers dismantle the overhead power lines and prepare the old bridge for removal. Final preparations for the mega crawler crane. And it will soon be down to him, crane operator Thomas Klei. This will be the first time he has to lift a bridge with the new crane rather than erect a wind turbine.
We're now positioning the slings so we can safely attach the bridge for the lift later. Everything is prepared. We're good to go.
The railroad bridge will be later suspended from these chains. They're made from a special hardened steel. Nylon ropes are used as extensions. Each can support a load of 50 tons. The exact weight of the bridge is unknown. Structural engineers have calculated it to be roughly 63 tons.
As always with such old bridges, you can't know for sure that it's really correct, which is what safety margins are for. I always add a safety margin when doing dismantling work, so it'll be all right.
The weight of the load and the distance the crane is operating at determines how much counterweight is needed. It will only be attached to the crane shortly before the lift and remains on the ground for the time being. Because the crane won't be able to move afterwards, it maneuvers to the lift position now.
Bit further, slew a bit, and stop. That'll do.
The positions of the counterweight and crane were precisely determined beforehand.
Everything was worked out theoretically on the computer, of course. Everything was planned out. So everything will hopefully go without a hitch in practice.
Only once the bridge is suspended on the hook will the crane operator know its actual weight. His colleagues can then increase or decrease the ballast if necessary. Final preparations on the bridge. Some ties still have to be removed to make room for attaching the chains.
We just need 4 people to pull the chains apart and attach them, then we can get started.
The chains are fed around the steel cross members, and the ends secured using large shackles fitted with bolts. Now, everything is ready for the lift.
You're always a bit on edge. I mean, you have to have respect for the job you're doing, but you're always a bit on edge.
The crane takes up the strain.
Okay, let's get off the bridge, all right?
The bridge doesn't budge. It's stuck. Due to the tension on the chains, it's under considerable strain too. Alarm. The automatic shutoff of the most powerful crane in service in Germany has been triggered. The reason for the alarm: the ground in the area of the ballast tray isn't completely level. When the tray was raised, the crane reported a fault, resulting in the emergency shutdown. The ballast attachment is adjusted, and the problem solved. 10 minutes later, the second attempt.
Rope up, rope hanging free, rope up again. It's coming now, good, it's coming. Good, okay.
The mega crawler crane now swings the bridge across the nature reserve. The counterweight is no longer resting on the ground, but is suspended in the air and can swing along with the crane. In order to set the bridge down at the right location on the staging area, the crane has to relocate by 10 meters. The tension in crane operator Thomas Klei gradually subsides. From his cab 60 meters away, he never even noticed that at first the bridge had jammed.
From up here, I've no idea when something gets caught a little or jammed. I didn't notice anything jerking.
Okay, Thomas, lower a bit more, set it down so it doesn't twist anymore.
Right on target. Once on the ground, the workers immediately get started dismantling the bridge, working from bottom to top. The steel in the century-old bridge will later be melted down and recycled.
Some of the bridges are no doubt old and very beautiful, but sadly, they too reach the end of their lives at some stage. That's just the way it is.
A yawning 28-meter gap is left, where until now, the railroad bridge spanned the Buchenbach Valley. And this needs to be closed as soon as possible so that the trains can run again. 2 days later, today, a temporary bridge is to be placed across the Buchenbach Valley. Prefabricated concrete elements that are attached to the old foundation with metal anchors serve as the beam seats. A steel girder is placed on top. The new bridge is due to be lowered down in 1 hour.
Everything must be absolutely perfect. We're working to almost millimeter precision, and the temporary bridge has a high intrinsic weight, roughly 90 tons. So everyone needs to know exactly what they're doing when the bridge is lifted in, and that's got to be planned in detail.
Meanwhile, the old bridge has been largely dismantled. The new one consists of 2 segments, one for each track. Their weight, 45 tons per segment. At the moment, conditions for the lift are ideal. The construction supervisor is optimistic.
The weather conditions are very good. Sunny with hardly any wind, ideal for this kind of job, in fact.
Up to now, at least. The mega crane swings the bridge section toward the railroad tracks. The workers on the foundation are waiting to secure it in place. Everything's going according to plan, and then suddenly the wind picks up. This leads to unexpected complications.
A gust of wind has caused the bridge to twist unexpectedly, and because the bridge isn't the same on both sides, it has to be installed the right way round.
So, the bridge needs to be rotated by 180 degrees. This can only be done using the control ropes that are hanging down from the ends of the bridge. But the ends of the rope are on the wrong sides of the gap. A decision is needed quickly.
He's getting another rope. We'll tie them together. Then attach them to your carabiner down there, and then run it over to the other side, where they can pull it to turn the bridge. That's the best solution. Do you think? Or do you have another idea?
No one does. So the workers transfer their control rope to the crew on the other side of the ravine and vice versa. And then it's time to rotate the bridge using muscle power.
It's turning easily now.
Done. The bridge segment can now be lowered.
It arrived the wrong way around, but we've rotated it in the air, so now it's facing the right direction.
The crane lowers the bridge centimeter by centimeter toward the foundation.
Thomas, slowly. Real slow now. Real slow.
The bridge is now suspended between the old foundations.
We're in. Now we have to find the right position. We need someone who can tell us where it goes.
For the fine adjustment work, the teams on both sides have to precisely coordinate their activities.
Stop. Thomas? Hans, how does it look on your end? I'm centered with the rail now.
Looks good from our side. We can now lower another meter, so we're 10 centimeters off.
Thomas, lower slowly. Can someone go down there, please, so we can push it a bit from below? Stop, Thomas. Hans, I'm still centered. Are you still lined up with your rail?
Thomas, slew a little bit more to the right. Go a little bit to the right.
It's roughly centered my end now.
We need to go 10 centimeters to you.
Okay by me. I was told that you over there need to adjust how far it is from the abutment.
Thomas, raise the boom real slow. Just the boom.
In this case, raising the boom will cause the bridge segment to move to the left.
Okay, it's coming. That's great. Keep going, keep going. Okay, Thomas, lower real slow. Stop a sec.
One of the workers goes onto the bridge. Because of the risk of falling, he clips his harness onto a safety rope with a carabiner. He has to run a nylon cord to the other side. It will help the supervisors to align the bridge segment so that the track runs exactly in the center later. Because the crane lifting points are also attached exactly in the center of the bridge, the nylon cord has to run through the shackles too. Once the cord has reached the other side, the fine adjustment of the bridge segment begins. It's still a fraction too far to the left.
3 millimeters.
A tiny correction by the crane operator, and the bridge segment sits in exactly the right position. The mega crawler crane, the LR 11000, now has to lift in the second bridge segment. Crane operator Thomas Klei slews the crane around and simultaneously drives forward toward the ravine. Then it's time for a break, because when he lowers the boom toward the bridge job site, the leverage forces increase. To counteract this effect, the auxiliary crane has to add more ballast.
We'll be ready to go in a moment. The guides are climbing down from the ballast, and then...
Thomas, we're finished. Crane is ballasted.
Understood. I'll raise the ballast and drive forward.
Thomas drives the crane as far as he can on the wooden planks toward the ravine so that he doesn't have to lower the boom any more than necessary. Aligning the second bridge segment is somewhat easier. The crew can use the first segment as a reference. The important thing now is that the steel connectors fit snugly in between the two segments. They have to be fixed on both sides with bolts. Cotter pins are used to secure them in place. Once the spacers are fitted to both sides of the bridge, the workers install the remaining connectors. Where it's too tight, they use a spreading device, similar to a car jack. It takes over an hour before the bridge segments are securely joined together. Then they're welded to the steel foundation girders. The workers just have to lay the tracks on the bridge and install the overhead power line. Then the trains can run here once again. The complicated task of swapping an old, dilapidated railroad bridge for a two-section temporary bridge has been successfully completed. A challenging lift for everyone involved.
When you always do wind turbines, you get into a certain routine as the procedure is always the same. The workflow for a project like this is completely different, and that makes it a whole new challenge for the crew.
But Thomas Klei and the other crane company workers can't put their feet up just yet. Tomorrow, they have to completely de-rig the crawler crane again. Then, they'll head to the next job site. The mega crane will return in a few years. Then the temporary bridge will have to make way for a new steel bridge. Only once it has been lifted into place can the staging area in the nature reserve be decommissioned.